Hi, my name is Simon. I'm a senior student majoring in data science. The presentation is for my capstone class final project. The project name is IEEE-CIS fraud detection, which is about fraud prevention system. And then the project is from the Kaggle competition. Now I would like to start sharing my screen. Before I start the project, I would like to overview about the project background and the data. I believe that we all have the experience that our cart has been declined when we are purchasing stuff. It could be either online purchasing or at the cashier counter. It was because of the unusual transition. In order to prevent the fraud transition, the bank has to decline the process. In this project, we can learn how the bank predict the fraud transition based on the data. The data I'm gonna use for this project is provided by the Vesta Real World E-commerce Corporation. The data is a really large scale data set and it has 1,000 of transition, which contain a wide range of features from device type to the product feature, card name, email address, etc. As we can see, this is my Kaggle notebook. Before I look my data, I imported all the packages that I will be using throughout this project. Then I start loading the data. We have a train and test data set normally. Since the data is very large, I load the data differently than the usual. There are two CSV files for the train data set. Those are the train ID and the train transition. I had to combine those two transition columns by using the merging method. I did a left merging on the transition column. As the result, we can see the number of row and the number of column, which is the really large data set. Then I deleted the train ID and train transition in order to avoid the memory problem issue. From this point, I will be only using this new train data set. Then I select the categorical feature and the numerical feature. First of all, I select the numerical feature first, and then I select, this is all the numerical feature, and this is the categorical feature. For this project, one of the big challenges I faced while doing this project was dealing with the categorical feature, because the categorical feature column contain many different levels. For example, this card one column contains 13,000 unique value. These variables are likely to represent the credit card company that has issued the card being used in the transaction. If we apply one hot encoding to this variable, we will get above 13,000 columns in the new data frame just for this one variable. So if we simply apply all those categorical columns, we will have a 10 of 1,000 of column, and our encoded data set will be too large to fit in the memory. To solve that problem, I evaluate each categorical feature. As we can see, there are 49 categorical feature. So I start evaluating those of the categorical feature in this code. In this code, it's how I evaluate the categorical feature. I remove the missing value, perform one hot encoding the feature. By doing those process, I get the 5 unique. For example, for this one P email domain categorical feature, I got the 5 unique important value. So I will be only keeping those 5 value and then use for my training data sets. I'm in this notebook, I'm not showing the same process for 49 categorical feature. So I do the same process to each categorical feature, and then those are the result from product CD and CD card 1, card 2, card 3, card 4, and then those are all 49 categorical feature. And it keep going, and after doing this process, I combine the numerical feature and then categorical feature for my pre-processing. For the pre-processing, I create the pipeline for the numerical feature, which involve imputation and scaling. For the categorical feature, which involve imputation and encoding. Then I combine this pipeline into one column transition object and apply the column transformer to the data set, and then I feed the feature and then processor. Now I'm ready to perform the model. There are 4 models that I will be using for this project. Those are logistic regression model, decision tree model, random forest model, and gradient booster model. These are the cross-validation these are the cross-validation code that I use for the logistic regression model. And here is to know the which model perform the better. Like I do the cross-validation in this here. The C parameter has the highest value, and then I perform the same process to each model. And then here for the logistic regression model, 97%, and decision tree model it's 98, and then for the random forest 99, and for the gradient boosted also 99, and gradient boosted tree and the random forest has the highest score among those 4 models. But when I submit the model, I get a higher public score for the gradient booster tree model. For that reason, I will be using that model for my test prediction. For the last part, I load the test data set. I do the same step that I did for the train data set, and I merge the 2 test ID data frame and test trans data frame. And in here, there is a one extra step that I have to do for the test dataset is the column, some of the column are different. So I have to rename all of those columns. And I delete the test ID and test trans, the same like I did to the train in order to prevent the memory issue. At the last session, I generate the test prediction. This is the code sample test submission, and then this is the test prediction. The probability of this is the gradient booster model prediction probability result. And to see it clearly, I put it into the data frame. This is the result of transition ID, and then the probability of possible fraud, which is very less as we can see here. And then I submit it to the computation. On the top, we can see the public score for this model. This is the public score that I received for that model is 0.89, which is not bad. The highest score I see is 0.9 something, which is higher. For the conclusion, I would like to talk about how we can improve the result. To improve the result, we can create the new feature which will help to improve the result. The higher accuracy is the better because it will improve the efficiency of fraudulent transaction alert for millions of people around the world, and that it will be helping thousands of business reduce their fraud loss and increase their revenue. And I would like to end my presentation in here, and then thank you so much for your attention.